Hello, hello, hello. So this is day three, and today I also have to do one thing more. I forgot, so I'm just doing that. And today we are gonna solve sliding window questions. So we are starting from sliding window questions. So this is it. Longest repeating character replacement. So let's try this. So what is this question? So we are given a string s and integer k, and you choose any character to change to uppercase English letter and perform this k times. So can I change only one character or can I change multiple? Let's see that. Uh, One question I have. Let's look at the test case. What will be the answer of A, B, C, and 2? Will it be 3? Yeah. So I can change any. So I can also change D. I can also change C. So I can change any. So now I think I'll have to run. Uh, so sliding window is expansion and decrement. Okay. So till I have K, I'll expand it. So I get A, and I'll write the most occurring number. So I'll store A and how many time it has occurred, I guess. Then I'll add B. So B and A both have occurred once. So, uh, but most occurring value in that window. So K will decrement and we have B, I guess, S, and then we get A. A will, so most occurring value will become 2, and the rest values will become length minus the most occurring value, and that should be smaller than K. Okay. Now I again reach B, so the most occurring value will be again A, because A occurs first. Let's say because A occurs first, so A is not replaced, and the rest values is 2. So 4 minus 2 is 2. 4 minus most occurring value, and 2 is greater than this. So this now let's say there was also a C here. So in that case, I'll because K will become 0. Uh, in that case, I will move I ahead. Now the most occurring value should change because B has become the most occurring value, and That is how I would do it. This will be the logic. Now, how should I implement it? That's the question. So, obviously, I know sliding window is the technique that I want to use. How will I find the most occurring value? How will I store that? One thing I just priority queue. Priority queue gives some max heap, I guess. It gives a max heap. Okay, how should I store the most occurring value? So, most occurring value in this I to J is nothing. I exclusive, J inclusive. Okay, so I to J is A. I to J is A again. Now B will be one value, K will become 0, and A again. Now we reach this B. So K is 0. So I can't take this. So I have to remove A, which is the most occurring value. Uh, I have to remove A again, which is the most occurring value. And I come to B, which is not A. So K will become 1, and I come to A. So now it would be A B, A B, and K will again become 0. K will again become 0. Now if I travel further, um, B should be the most occurring value and K will should stay 0. But how do I make that change? That change making is the problem for me right now. Uh, how do I know? Let's see the solution only. In the problem, we are given a string consisting of sliding window plus binary search. Since the question asks us find the longest substring that satisfies that, we can start by generating all possible search. Right. Uh, A becomes 2, B becomes 1. Now this seems to be a nice idea. Okay, one man, one man, one man. So count is 2. Count is again 2. Is K 1? What is K? Count becomes 1. Count becomes 0. So will we do this for all the numbers? We should not do this for all the numbers. No? We'll have to watch a video on this because this goes over my head a lot right now. I so they are doing the similar thing that I wanted to do, and I understand that, but it's difficult to grasp.
longest repeating character replacement. So what is the problem exactly stating? It's stating that you'll be given a string which will have all the uppercase letters. You'll be given an integer k. Now what does this particular integer signify? It signifies that you can pick up at most k characters, at most 2 characters from this given string. Assume I can pick up this particular A, I can pick up the last A. Any W, you'll have to figure out the longest substring which has all the characters. So substring, pick up this one to convert at, I can pick up this A. So A, find out that at max the length that you'll be able to force that you can think of. I'll generate characters I need to change. This B, all the A's to B's, minimize the conversions. You look to minimize the conversions. Thereby, this is what you'll try to do. You'll try to pick up the minimal conversions. Correct? Now, how do I figure out the minimal conversions? It's very easy. Can I say double A, B, A, B? This has A 3 times, B 2 times. So technically, I should convert all the B's instead of converting all the A's. Whatever, like whichever character appears, maximum number of times. I'll not touch it. I'll touch all the others. Imagine you have a substring which is looking something like A, B, C. And A is appearing 3 times, B is appearing 2 times, C is appearing 1 time. So you'll try to convert B and C instead of converting A, correct? You'll try to convert B and C because that will take 3 operations. Understood? So I know one thing, the number of conversions, if I have to figure out a formula, double A, B, C. For an example, for the string, if I ask you how many conversions do you require, can I say max frequency, which is max of F, minus the length, or can I say the opposite, like length? So the length is 6 minus max frequency, which is 3. Hence comes out to be 3. 3 is the number of characters that you need to change. Length minus max frequency is the number of characters that you need to convert. Okay, I figured it out. So what was my brute force? My brute force was to generate all the substrings. Now I know that the first substring will start from this character, which is A. The next one will be double A, B, A, and so on till the end. The next set of substring will start from this particular A, which is A, B, A, and so on. The next set of substrings will start from here, which will be B, A, B. So what I can do is, I'll be like, okay, I know the formula is length minus max of F. So I just need to figure out the maximum frequency. And I know that we have uppercase characters. So I can maintain a hash array of 26 size, correct? Which is going to tell me how many times a particular character appears. That's what I'll do. Let's try to pick up. First, I'll try to pick up A. So that's my first substring, right? So I'll pick up A. And I'll say A is appearing once. Next, I'll pick up A. So that will make it 2. So I can keep on updating the frequency, correct? So let's try to write this in pseudocode. So if I try to write this in pseudocode, I know that I'll always start from 0 and then every possible character will be a starting point of any substring, okay? And after that, I know that I need a hash array. So maybe I can keep a hash array which is initially assigned to 0. I also know that in substring question, I start the j from I and I go on till n. Perfect. Can I say that the hash of I will be updated? Hash of s of j, because that is the character, that's going to be updated. I need to keep a track of the maximum frequency, right? So maybe I can also update, I can also carry a max of f, which is initially 0. And whenever I update, I can compute the max of frequency to be max of the previous frequency, hash of s of j. You can write it in one statement as well. I've written it in 2 statements to make you understand. Okay, I've updated my maximum frequency as well. What after this? I need to figure out the number of changes. Can I say the number of changes will be the length? What is the length of this particular substring? J minus I plus 1, very obvious, minus max of f, correct? Now, can I say this is only allowed if the changes are under k, are lesser than equal to k, then only it's allowed. And in that case, I'll have to keep the maximum length track. So what I can do is I can say max length, comma, j minus I plus 1, if that is the case. And if it doesn't satisfy, in that case, I'll go to else. Do I need to accumulate the other characters? Imagine you have accumulated this, and after this, when you get this b, and it doesn't satisfy your condition, do you take this b? Because if you take this b, it's not meeting your condition of at max k. You'll not be able to take this. So what you do is, you straight away say, hey, listen, I'm going to break out, and the for loop ends. And eventually, what you can do is, you can head over, and you can print the max length. That's it. That is the extreme naive solution that I can think of. Now, what is the time complexity? Can I say initially I'm taking a big O of n? I am. And again, I'm taking another big O of n. So that's an overall of big O of n square. Am I using any external space? Yes, I am. Big O of 26, but nothing more than that. So that's what I am using. That's it. That's the brute force. And this is where the interviewer will not be happy with you and he'll ask you to optimize it. So you'll have to optimize big O of n square. And if I'm looking to optimize n square, that means I'm looking for an algorithm around big O of n. And the problem is involving substring or subarrays, right? So which algorithm comes to your brain? Yes, 2-pointer and the sliding window. We've already done a lot of problems on 2-pointer and sliding window. If you haven't seen it, please go back and watch it because we're going to follow the same pattern. So big O of n and 2-pointer. Initially, we start with the left pointer and the right pointer and we keep it at the 0th index. what are we looking at? We're looking at a maximum frequency. So maybe I can keep a variable max frequency, which keeps a track of the maximum frequency. We're looking for longest substring. So maybe a max length. If I have to figure out the frequency, I'll have to keep a hash map as well of size 26. So a hash map. So initially, we are standing at A, which is the 0th index. Put it into your hash map, A, 1. So once you put it into your hash map, can I say that the max frequency will be updated to 1? I can. Now what is the next thing? You check if this is a valid segment or not. How do you check? What is the length? 1. What is the max frequency? 1. What are the number of conversions required? 0, because this segment has all the characters same. So I don't need any conversions. Thereby, this is a valid segment. And if this is a valid segment, I update the length to 1 because the length is greater than the max I already have. Frequency to 2, the max frequency gets updated. Now what is the next thing? Check if this segment is a valid one or not. The length is 2, the max frequency is 2, number of conversions is 0 because double A, no conversions needed. Thereby, I can update the max length to 2. After this, I'll take the R, I'll move it here. Next, is this a valid segment? 2, 3, yes, it's frequency. No, because the max frequency are not. In order to do that, the length is 4 of this segment. The max frequency is 3. Number of conversions required is 1 because I'll have to convert this B to A in order to make all the characters equal. So thereby, length can be updated. After that, will the max frequency get updated? No. I'll check if this frequency, this segment is valid. Now this time when you move R, this is C, which is appearing once. The max frequency will not get updated. But when you try to check if this is a valid segment or not, the length is 6 and the max frequency that appears is 3 times. Number of changes required is 3. Hence, it's not possible. Hence, it is not possible. So what you will do is, you'll be like, fine, if this is not possible, I'll have to trim down my window. Because this is my window. I'll have to trim it down. If I'm trimming it down, what I'll do is, I'll take the cell, I'll move it forward. So if I move forward, the first thing that will happen is I'm removing 1A. So the frequency decreases. So basically, I remove this A. Next, if I remove this A, I'll have to cross-check the max frequency again. What is the max frequency now in this hash map? That's 2. So what you'll do is, you'll update it to 2. The max frequency now is 2. Is this segment, my bad, is this segment possible? What is the length? The length is 5. The max frequency is 2. It's coming to be 3. Number of conversions required is 3, which is not possible because I'll have to convert this to AAA. Hence, not possible. If it is not possible, you'll again end up removing another A. And if you remove another A, this will reduce to 1. And after that, you'll move your R. So you shrink down the window from the left. You shrink it down again. If you shrink it, will the max frequency update? No, this time because you still have another 2. Okay, let's check if this is a valid segment. The length is 4, the max frequency is 2, and this is valid. So you can say this is valid. But what is the length? The length is coming to be 4, which is not allowed because I already have a 5. So this is not the longest. So I'll simply go ahead and take R over here. And I can keep on doing this. I can keep on doing this till this R exceeds my boundary. And eventually, I'll have my max length. Couple of points to remember. Whenever you're removing A, make sure you update the max frequency by scanning through the entire map. We can optimize that afterwards, but as of now, remember it. So we know what we are looking forward to do, right? So can I write down the pseudocode? Maybe yes.
Let's write this. Okay, it is not an elegant solution. I was hoping like we could find the max frequency much easier, but it's okay. Yeah. Mm. Is equals to 0. Yeah. Mm. Okay. Now we need cool for loop of yeah. P of S of A plus X. So I'll add A to the now. Let me be back 1 month. Mm, mm, Masih dulu. Ah, ya. Betul, betul. Ya, masih itu. Ya, bukan betul. Macam itu. Eh, nah, aku memang betul saya. I know right now the max character would be TN is equals to S of 0 and max uh, max frequency is 0. So if S of J is equals to CN and F plus plus. Okay. And F plus plus or and do I need to do anything? Do I need to make a check? No, I think not. Yes. If I get D, let's say. So in this case, A will come, it will just increase the max frequency, which is okay. Now, ha, 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 ha. Hey, 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 hey. Now, if it's not, then I come to B, let's say. If let's say I can then is equals to J minus I plus 1. Okay, length will be this.